Alright, here's the 9.4 notes. This section is all about testing involving paired differences. So the first three sections involved one particular situation, one sample, one thing, and we're just testing it whether it was less than, greater than, or not equal to. Now we're going to get into two samples. So 9.4 is going to involve dependent. So they are kind of talking about the same thing. They're dependent upon each other. And then 9.5 is the big one, the long one, where we're going to end up having different independent samples. So what's a dependent sample? Hopefully we all know by now. Members of the pairs have a natural matching characteristic. So an example, I've already talked about this before. If you go on a diet, you might take your weight before the diet and then take your weight after the diet. That's a dependent situation. It's the same person that you're going to take the weight of. Okay, so the same group, the same person, and that's going to be what happens the whole time. And what we're going to do is test to see if these dependent samples are significant. Okay, what's an advantage of using paired data sets? Okay, it reduces variability just because it's the same people. Reduces danger of, because a lot of times what can happen is you can have some extraneous, uncontrollable things that happen to skew results, and they're just more accurate if you can take a before and active shot of what you're doing. Alright, so what we're basically going to do is you're going to be given, and in most of these problems it's literally going to be set up nice for you in a table format, and we're going to find the differences. So what you need to do on your formula sheet is I want you to kind of zone in and look at, and it says for paired differences D is what it actually says on your formula sheet. Paired differences D, you need to find this t-score. So in this problem you're going to have t-scores. So yes, you're going to need your blue sheet. Alright, and we're going to have a thing that I call D-bar, and that's going to be your average difference in your situation. So we're going to take a table of values and we're going to find the mean of that value. And D-bar is kind of like X-bar, where you find the average of the x's, except you're going to find the average of the differences. And that's why it's D-bar. And then standard deviation, we're going to have to find that too. So you're going to need your calculator. You're going to have to do some of these things. Before we get to an actual test, this is what's going to happen every time. The null hypothesis is that we're going to predict that there is no difference, period. And this literally, if you have to do this, is your null hypothesis every single time. Your null hypothesis is the mean difference is equal to 0. We're going to assume there's nothing wrong, and we're going to try, or nothing different about it, and we're going to try prove it wrong. We're going to try and make it show a difference. Then your alternate hypothesis, hopefully are kind of straightforward if you think about it now. Notice the null is always the same. Doesn't matter which one you're doing, it's the same. And then if it's a left-tailed test, we think it's less than. Left, less. Okay, right-tailed test, we think that the difference is greater than 0. Okay, or essentially the first group is bigger. And then if it's just different from, that's a two-tailed test. Hopefully no different than any of the other two-tailed tests that we have done. So that's this scenario, and now what I'm going to do is do one example for you. Okay? Once again, I just want to do one example, and then we'll do more in class. So here's what we're doing. We want to determine at a 5% level whether a particular diet causes significant weight loss. And I purposely only have a couple people in here. So what you're going to see in your notes and in your homework, you're going to see tables. It's going to be set up for you like this. So we have 4 patients, A, B, C, and D. Here's the weight before, and then here's the weight after. And we want to see if there's a significant difference at the 5% level, okay, of the diet. Actually, is what we're looking at, of the diet. So, what do you need to do before we can actually set up our test at all? We need the differences, our D-bar. So what you're going to do is you either need to, on your paper by hand, actually subtract these. 177 minus 162 is it actually must be going after before 4. So be careful. It's however you want to do it. Just make sure you're on the same page. Okay? After before 4. We think the after is going to be significantly lower. So maybe we want to go after minus before. You can do it either way as long as you know it. Okay? So I'm doing after, subtracting the before. So 162 minus 177 is negative 15. And if you do all of them, that's what shows up. Now, if you do not want to do all of these on your own by hand, and you're going to have to put this in the calculator anyway, you might want to just enter all the data. If you put L1, these 4 numbers in L1 right here, and then in L2, you put these 4 numbers here, and then if you go up and highlight L3, and then push enter, you can tell it to go L2 minus L1. And if you push enter, these numbers should show up in your calculator. Okay, so you can actually have the calculator do all of the work for you if you want. I would highly encourage you to do that when 10 and 12 of them are. Or you just do all the work by hand, and then you will end up wanting to enter your answers into a list. Either way, how do I calculate the mean and the standard deviation? You need to do your first variable stats, the first var stats, okay, of your list. And if you do that, I would practice this because this is the only problem I'm going to have you do online. All right? If you put these 4 numbers into a list and do your first var stats, your x bar on your calculator, remember that's just the mean. This just means d bar, the mean of the differences. It just means the mean of those numbers. Should be negative 4.25. And then your s of x is just your standard deviation of the calculator thinks it's the x values. We're denoting it s of d as the standard deviation of the differences. It's no different. We need to calculate those 2 numbers. That's the 2 numbers we need to have in order to find a t-score. Okay? So once we have that, it's pretty straightforward. How do I set up my actual test? Okay, your null hypothesis every single time. I think my differences are nothing. I think it's the same. So it'll always be the mean difference is equal to 0 every single time. Okay? What's my alternate hypothesis? I think the mean difference is less than 0. Okay? Because I decided to do the after minus the before weight. And if you think about a diet, I think these numbers are smaller. So I'm deciding to do that. My difference, when I think these numbers are larger, I'm thinking negative numbers. So I think my mean difference is less than 0. All right? If you flip-flop it, and you just did the before minus the after, I should expect the weights or the differences to be positive. So your alternate hypothesis then would be the mean difference would be greater than 0. It's all about how you set it up. On a test and a quiz, I'm going to have to read everybody's scenario. You have to tell me what you want to do. In either case, you want to find your t-score for the d-bar statistic. How do I do that? Okay, you literally go to your formula sheet and find the t-score. And this is really easy, actually, once you it's the same flow once you figure this out. Once you find your d-bar from your calculator, which was negative 4.25, you dump it in. Minus the mean difference that we think. Well, notice this is still the null hypothesis, or your h of 0. What did we say it was equal to? We think the difference is nothing. So it's always going to be minus 0. That'll always, every single one of these dependent scenarios is going to be minus 0, which is really nice. Standard deviation of the difference. We just found that on the previous page. Divided by the square root of n. N just refers to the number of people or things in your sample. So we had 4 people, the person A, B, C, and D. So we divided by the square root of 4. And in either case, you get your t-score. Alright, so now we have a t-score that's equal to negative 1.17. So now is when you have to get your blue table, and we have to find your actual p-value. And in this case, it's going to be a p-interval that you're going to end up having to find. Now, I have it all written out for you, but remember, your n is equal to 4. So degrees of freedom is 3. So now you're going to have to go into your table. Degrees of freedom, 3. And as you move across, we need to try figure out what 2 columns. Now I have negative 1.17. Now do you guys notice a negative 1.17? No. We need to, remember it's the absolute value with a t-score. So where is 1.17 going to fall between? Alright? 1.17. Degrees of freedom 3. So it's between what? And this one, I must have a different table that I looked at. Okay, so 1.17 falls between, if you guys follow on your T table, you guys agree it falls between 0.765 and 1.423. Hopefully that you think that that number falls in between there. So if that's just the first and second column, am I looking at a one-tailed area or a 2? What kind of test am I doing? I think it's less than, which is just a one-tailed test. So if I go to the very top row, my p-value, I said the p-value is greater than 1.25. In all actuality, it's going to be between 1.25 and 0.250, which it is greater than 0.125. So either way, this is technically true. This is giving me an interval that's, you know, between 0.125 and 0.25. In either case, we are going to now finish our test. How do I finish a test? What do I compare it to? It goes back to my alpha. What was my alpha? Okay, the alpha was 0.05. So I have to compare that to a number that is greater than, so my p-value, the only way we reject is if my p-value is less than my alpha. Well, what is my p-value? It's at least 0.125. My alpha is 0.05. This is way bigger. So that means I cannot reject it. Okay? So what do I conclude? I actually didn't put a... So at the 5% level, okay, we conclude that we cannot reject the hypothesis that there's no significant difference in weights before and after the diet. Okay, so, or you could write as at the 5% level, okay, we fail to reject our null hypothesis, which means that there is no difference in weights before and after the diet. Alright, we cannot conclude any difference at all. Now, if you kind of go back, why do you think that it didn't work? Because if you look at the differences, there was one that was really good, but the other ones weren't. So notice how this test can, one outlier, if you want to think about it, could heavily skew your data, but this test kind of equals it out, and it looks at all of the data, not just one big one. Okay, so that is your example of a dependent situation. We will definitely work on these in class tomorrow as we kind of continue on with this chapter. Here is your assignment, and you guys have a wonderful day.